The determining what we will build, collecting the data, like, looking up happy faces for humans, cleaning and labeling the data. That's sort of like what a data scientist typically does. Then training the model as well is something that they do. So now let's talk about evaluating and visualizing the results. So we mentioned here, you use label box to label what this outcome is. So this is a lady who has a happy face. So this is something known in computer vision as a bounding box. So you have a bounding box around it in the image. And then you label it, because this is supervised learning, guys. You have to label it. And you have to determine that, is this something you enjoy? So some of the students in our core classes get really excited about labeling these images. It really depends on you guys. And that's what I want you guys to know, is that you're under no obligation to feel a certain way about a certain field. Like, just because somebody likes this job or thinks it's cool doesn't mean that you will feel the same. It's all a personal preference, right? So this is something that's known as a confusion matrix. So this is a confusion matrix here, guys. So why is it a confusion matrix? Well, when you come up with a model like a neural network model, what happens is that it can predict these outcomes, predicted label and then true label. No detection, we can ignore it. No detection just means that it did not detect, that you were a human being. Like how Sarah and I think Nicole weren't detected on the first day with their COVID mask. So similarly, we have happy, neutral, surprised, angry, sad from our emotion detector. We have multiple emotions here. And we had labeled them. And now what happens? We're training our model, using forward propagation, back propagation, right? And then we're evaluating and visualizing our results here. So now we have the true label, guys. We have our true label, which is the actual outcome. What is the photo actually of? Like, what is a person's true emotion? And you can ignore this if maybe there's no human being here, no human being. That's what no detection means. And this is what the prediction is. So what do you guys think about this value here, about this 53%? 1 second, I'm just going to, what do you think this represents? What do you guys think that this represents?
How sad the model looks.
Okay, you're thinking in the right direction. So if you're, so like, this is the truth. So what is the truth at this 53%? Like, what is the truth? Like, what is the person actually? Like, what emotion does a person actually have? Yes, thank you, Journey. Yes. The person is actually sad here. Do you guys see that? The truth is that the person is sad. And what does the prediction say about this person? That they're sad as well. So if a person is sad, then what percentage of the time will it correctly predict that they're sad? 53%. Yes, awesome. So what this means is if a person is sad, then 53% of the time, the model will correctly predict that that person is sad. So you look here and you look here. So there's something that in math classes, you guys will talk more about it. This is called a main diagonal. So you guys will see that along this main diagonal, what do you guys notice about this? Oh gosh, what do you guys notice about this main diagonal? Oh, I can't even draw for my life. Okay. Simple circle, we could do this. Okay, yeah, okay, that sounds okay. Okay, so what do you guys notice about this main diagonal? Anything with regards to the predicted and the truth? This main diagonal? This confusion matrix is like, how confused is your model? It's like giving you the health of the model that you've come up with. Like you've trained it. It's almost like you're viewing your SAT scores. How often it is correct for each emotion. Yeah, so if you guys try adding these up, they may not add up to 100%. They should add up to 100%, but that's just because of rounding. So we rounded it to 2 decimal places, but in reality, like, so it does add up to 100%. Each row should sum up to equals 100%, each row. Each row here adds up to 100%, each row to 100%, each row adds up to 100%. So that's the thing. So each row needs to add up to 100%. And what this main diagonal is the accuracy, because what you notice is that this is happy and this is happy, the same truth and prediction. This is the actual situation, the true emotion. And this is the predicted emotion that our model predicts. It's like we could have one for who has a mask on, doesn't have a mask on. If we could have one for is Obama, like if we were doing the Obama, is it Obama or not? Is Obama, is not Obama, could be the outcomes. And then is Obama not Obama, right? And then we could see the number of times. And this is the percentage based on like how many times we've tested it. So this is saying that 79% of the time, if a person's happy, this model will detect the person's happy. So this main diagonal is the accuracy of the model. That's what's measured here. And anything else is an error. Because if you're sad, 53% of the time the model will actually detect you're sad. What is the next highest number that it will detect? This is the actual emotion, and these are all the predictions, the percentages. So 53% of the time it will detect you're sad. What is the second highest emotion it will detect?
Neutral.
Yeah, what percentage is that?
22%.
Yes, awesome. Thank you. So it's going to determine, so thank you, David. Yep, it's going to determine that you're neutral. Like if you're sad, 22% of the time, it's going to determine that you're neutral. So if you're sad, 6% of the time, it'll think you're happy. Maybe it would like, if you're crying, you find the verge of crying, like, who knows, it could look like you're happy, maybe 6% of the chance. 6% of the time, it might incorrectly think like if you're grimacing, like sometimes I've done it, like I'm a crier, guys, but like, sometimes I've looked like I'm smiling and then I'm like trying to fight back tears sometimes. So it looks like, it could look like that. Then 22% of the time you could look neutral, right? Like imagine if you're sad and you're really depressed and you're just not showing it. You could look neutral, but you're really like fighting back, like, or hiding your emotions. So 20, that's why it could be high. So we might need to figure out how we can tell apart between sad and neutral better. Like maybe we need to give more images about sad and neutral to help it. 0% of the time will it think you're surprised, because surprise probably has like big eyes or something. And that's, who knows, that might not show when you're like really sad. And some 12% of the time it might not. Maybe it can detect 6% of the time you're angry. Maybe you're grimacing and you look like, it all depends when you're sad. Like in this example, sad has she has a tear coming down. So it really depends. So if you're surprised, 93% of the time, it's going to correctly predict you're surprised. About 5% of the time, it's going to predict you're happy. You guys know probably why it could be like that, or what do you guys think? You guys think they're pretty similar, right? Like maybe like big eyes, or like, like, oh my gosh, it could look like you're happy, right? 5% of the time. Yeah, you're like happy, surprised. Yeah. So what you really see is that we should really improve on sad, because it's 53%. And then what's the second one you guys would want to improve on? Which emotion would you want to improve on next? Neutral, yeah, because it's 70%. So this tells you at a glance, especially because we have many different classes. So like our neural network would have many outputs. It would either have, like yesterday's was either Obama or not Obama, or like for the neural network. So this one would actually have 5 classes. And the one that the neural network predicts that has the highest value between 0 and 1 will be the one that we go with. Remember yesterday we were looking at the output layer in the neural network. The one that's the highest is what we will go with. So that's sort of how you guys can see this over here. Angry, sad, surprised, neutral, happy. and you go with the one that has the highest value. And then this will tell you what you have to improve on as well, where you need to collect more data. And these things that are not on this main diagonal are all the mistakes. I personally think that this one is a really bad mistake. Do you guys think why? I mean, maybe if you agree with me, do you guys know why this could be not a good, like why this could be a bad mistake to make? But what does this mistake mean? And not just that, but why do you guys so think in terms of mental health or other things? Why could this be a bad mistake to make? Yes, somebody said it like they're sad, but the machine thinks they're happy. Yes. Imagine if you had this as a dog emotion or a pet emotion, and you're trying to determine how your pet's feeling, and then they're actually sad, but this thinks that they're happy, and you neglect it. Right? So imagine, so many people like could feel like suicidal or upset or vulnerable or just really they might need attention. And you might, if you have a machine that's predicting that they're happy, you'll be like, yeah, they're happy, blah blah blah, blissfully unaware of the fact that they're really sad. So I think that this one should be improved. Because I'd rather you think that someone who's happy is sad so that you can like check up on them. They're like, no man, I'm really happy, I'm great. But the other way around, if you think that they're happy and you just don't like check up on them and they're really sad, then that could not, then that might not go so great, right? If somebody's sad, they might need some more attention or care. And if you think they're happy, if you predict that they're happy when they're sad, you might neglect them. So that's my thought, but it all depends. And then we have ways to maybe see how do you prioritize the errors that you're making, like are some errors created equal or not. So that's an approach you can check up on. But so now we talked about all the steps in this so far. So we talked about, determining what to build. Product managers usually do this. Then you collect data, like you have to figure out what are happy faces for humans to use, clean the data, label the data. You can collect it online. You can collect it from, your own photos, take photos, ask people to pose for you. You train the model as well, and then you evaluate it using confusion matrices, using other approaches. Then you deploy the model to serve the customers and you continue to monitor the performance. So what you'll do then is then you could use Flask, it's a micro framework, easy to learn and get started, perfect for a small project. One-click deployment, it's just perfect for a small project. So what that means is like a COVID mask detector. People can use it. You guys can go on the site, play around with the projects, see the YouTube videos for that too. So we talked about that. Happy Halloween! And in the spirit of a happy Halloween, happy Halloween! In the spirit of Halloween, I will follow suit as well. So happy Halloween. I'm a happy badger. Yay, woohoo, go Badgers. I hope you guys have a wonderful, spooky Halloween. And if you really want to give little Yangshi and me a nice Halloween treat, please subscribe to my channel and please let me know if you have any questions at all. Thank you so much. And let's not forget dear May as well. So she's also going to try to be a happy badger.